Hello and welcome to session 50. Hello and welcome to session 15, compound measures. Let's get into this. So by the end of this session, learners must be able to calculate average spend and density using the formula. Learners should be able to use compound measures in order in other contexts, including rate of pay, calculate distance covered and time taken using an appropriate formula, and use compound measures in contexts including speed and distance. So compound measures, in previous units, we've looked at measures of length, weight, and capacity. Here we will consider some compound measures such as speed, density, rate of pay, etc. We need to always take care that we are using the correct units throughout any calculation. So speed, you probably have some knowledge about speed. You can walk about 4 miles per hour, run about 10 miles per hour, and cycle about 20 miles per hour. On a motorway, you're allowed to travel 70 miles per hour, but often cars go faster, and other fastest trains travel about 125 miles per hour. What does 4 miles per hour actually mean? Well, 4 miles per hour means that if you continue at this speed, you will travel 4 miles in an hour, where the high-speed trains travel 125 miles within the hour. We calculate the average speed by dividing the miles traveled by the time taken. Speed examples. So Lucy drives to Plymouth to Southampton. The distance is 161 miles in 3 hours and 30 minutes. What would be her average speed of her journey? So the solution here, we need to work out Lucy's average speed in miles per hour in the distance traveled divided by the time taken. So that would be the distance is 161 miles and the time taken is 3 hours and 30 minutes. So 30 minutes is half an hour, and so the time taken is 3.5 hours. This is a given. So average speed divided by 161 miles per hour divided by 3.5 equals 46 miles per hour. Care must be taken to put the time into hours. Note also that we have a formula for the average speed as below. Excuse me. So the average speed is the distance traveled divided by the time taken, and there we are. So we can have a look at these and see how we get on. So have a little go with Norwich to Carlisle. Start time is 2 o'clock. End time is 7. So 2, 3, 4, 5, 6. So that's 5 hours, isn't it? Okay, shall we have a look? So the first one is 56 miles per hour. The second one is 37.5 miles per hour, 48 miles per hour, and the last one is 34.8 miles per hour. Did you get those all right? So distance traveled then, as well as we calculate the speed and the given speed at the time, we calculate the distance traveled. For example, if you travel 60 miles per hour for 3 hours, you will travel 3 times 60 equals 180 miles. Similarly, you can calculate the time taken for a journey by dividing the distance by the time. If you travel 150 miles in 3 hours, then the time is taking you 150 divided by 3, so you are traveling 50 miles an hour. The formula we have been using here are summarized. So we've got speed equals distance divided by time, distance equals speed times time, and speed equals distance divided by speed. So Jane drives at an average speed of 45 miles per hour on her journey of 135 miles. How long does this take? So we're going to do time equals distance divided by speed equals 135 divided by 45 equals 3 hours. So let's have a look at this one. Chris cycles an average speed of 8 miles per hour. If he cycles for 6 hours and a half, how far does he travel? So we can now do distance equals speed times time equals 8 times 6.5 miles. So that's 52 miles. So the density then, this is another compound measure for how dense a material is. For example, a container full of sand would be much heavier than a container full of air or full of bubble wrap. This is because it is much more dense than air. Density, weight, and volume are connected by relationships. Density equals weight divided by volume. Weight is density times volume, and volume is weight divided by density. So density examples then. A metal block weighs 2 kilos. The block has a dimension of 5 by 10 by 20. Calculate the density of this metal block in grams per centimeter square and kilograms per centimeter square. So we first need to calculate the volume of the block. This will be 5 times 10 times 20 equals 1,000 centimeters square. So the weight then is 2,000 grams because 1,000 grams, 1,000 is 1 gram, 2,000 grams. Good. So the density, so it's the weight divided by the volume. So it's the 1,000 centimeters square divided by, no, sorry, it's the block of 2, weight is the top one, 2,000 grams divided by the volume, which is the 1,000 centimeters square, equals 2 grams per centimeter square. So the density is 2 divided by 1,000 equals 0.002 grams per centimeter square. Note the density has not changed, but the value changes with the units used. Other compound measures, average scores. So average scoring rate in football. Alison scores 27 goals in 40 matches. Calculate her average score. So that's, we need to know goals per match, goals per minute in less than 90 minutes, and goals per hour. Solution then, scoring rate per match would be the total goals scored divided by the number in the match. So that's 27 divided by 40 equals 0.675 goals per match. The scoring rate per minute would be then the 27 divided by 40 divided by 90, as there are 90 minutes in the game. So that's 0.0075 goals per minute. And scoring rate per hour would be the 27 divided by 40 times 1.5. As each game lasts for 1.5 hours, that equals 0.45 goals per hour. So looking at then this example here, so Moongate taxis have a fixed charge of £2.50 and 20p for every 100 miles travelled. How much will it cost to travel 1.5 kilometres? So we're going to have to work out kilometres and miles, aren't we here? So, excuse me, as it costs 20p for each 100 meters, we need to work out the cost of 1.5 kilometers. We can write 1.5 kilometers as 150 meters. So the cost of the distance travel will be 15 times 20p equals 300. So that's an additional £3. The total costs to the fixed charge of £2.50, then it's £2.50 plus £3. That's £5.50. An example here, you're offered 12.5 hours of work per week in a local kebab shop at the rate of £7.50 an hour. How much would you be paid in a week and a year? So the solution here then is you're paid £12.50 time. You work 12.5 hours times that by £7.50. That's £93.75. For 52 weeks, you'll be paid there's 52 weeks in a year, so you will be paid 52 times 93.75. So that's £4,875. You will not, of course, actually get that amount in pay, as both tax and national insurance might be payable. Okay, good. So at the end of this session, we've covered calculate average speeds and density using formulas, use compound measures in other contextuals, including rate of pay, and calculate the distance covered and the time taken. And finally, we've used compound measures in contexts, including speed and density. Please make sure that you complete the worksheets, do your activities and checks, test your progress, and check your records. Thank you very much for watching. Hopefully that was of some help, and I will see you in session 16. Take care. Bye for now.